Welcome to another exciting chapter of DIY electronics repair. Today we are doing LCD TV inverter circuit board repair. If your LCD TV is not working, flickering or not displaying any image, there is a good chance that the inverter board is the culprit. But don't worry, I will explain the process step by step. First of all, let's understand what the LCD TV inverter board does. This critical component is responsible for powering the backlight of the TV screen. It takes DC voltage from the power supply and converts it to high-frequency AC voltage to illuminate the LCD panel. Now let's get to know the components on the circuit board. Connection sockets of CFFL lamps. Thermal pads. It is used to transfer the heat generated on the inverter transformers to the cooling metal surface. Before working on the circuit board, I removed the thermal pads. High voltage transformers. The inverter board typically contains one or more transformers that are used to convert the low voltage DC power from the power supply to the high voltage AC power required to drive the backlight. Transistors. Inverter boards have an array of transistors, usually metal oxide semiconductor field effect transistors MOSFETs, that control the flow of current to the backlight. These transistors quickly switch on and off to create the AC voltage needed for the backlight. Capacitors help filter and stabilize the voltage supplied to the transistors, reducing ripple and providing a stable power supply to the backlight. Inverter boards contain control circuits, which may consist of microcontrollers or other integrated circuits. These integrated circuits regulate the frequency and duty cycle of AC power supplied to the backlight to control its brightness. Some inverter boards have fuses for overcurrent protection. These fuses prevent the components from being damaged by blowing in case of a fault in the circuit. This inverter board consists of two parts symmetrical to each other. The control IC that commands the B channel controls the high voltage transformer using MOSFETs. The transformer sends the high voltage it produces to the CFFL lamps through the connection sockets. The control IC of the A channel also controls the high voltage transformer as in the B channel. I am checking capacitors on the circuit board. In order to do this, I remove one leg of the capacitors from the circuit board. I attach the probes of the multimeter and put the multimeter in the capacitance measurement position. In capacitor measurement with the multimeter, if the value written on the capacitor and the capacitance value measured in the multimeter are close, the measured capacitor is sound. All capacitors I have measured are okay. I solder the legs of the capacitors onto the circuit board. Now I will check the transformers. I disassemble the transformers from the circuit board. To facilitate the disassembly process, I apply flux to the feet of the transformers and freshen the solder. In the disassembly of the transformer, I apply the hot air gun on the pins and lift it up slightly with the tweezers I placed under it. I removed the transformers from the circuit board. Let's check them out now. High voltage output terminals of the transformer. Secondary tips. Drive control input terminals of the transformer. Primary tips. The wires connected to the primary winding are usually thicker or have a smaller gauge than those connected to the secondary winding. This is because the primary winding uses the higher current to raise the voltage. I take the multimeter to the resistance measurement range. The primary winding typically has lower resistance than the secondary winding. I'm measuring the secondary winding. I'm measuring the primary winding. The transformers I've measured are okay. Now I will check the Mosfets on the board. In order to better show you this control, I disassemble the Mosfets from the circuit board. I removed all the Mosfets on the circuit board. Before you start Mosfet measurement with a multimeter, you need to know the Mosfet pins. I take the multimeter to the diode measuring range. Before starting the process, I touch all the pins of the Mosfet with my finger. The black probe of the multimeter is touched to the source pin, and the red probe to the drain pin. No value appears on the multimeter display. While the black probe is connected to the source pin, the red probe is touched to the gate pin and pulled, and then touched to the drain pin. The value appears on the multimeter display. Mosfet is triggered. I touch all the pins of the Mosfet with my finger. If the Mosfet is in transmission, it goes to cutoff. I am swapping the probes. The red probe is fixed to the source pin, and the black probe is changed to the drain pin. The value appears on the multimeter display. The black probe is touched to the gate, and the value does not appear on the multimeter display. I checked the MOSFETs on the circuit board as shown, and all MOSFETs are okay. The circuit board has flexed over time with use. As you can see, there is a warp on the circuit board. There is cold solder at the solder points of the SM components caused by this warping. The fault of this board is solder cracks. I made this video to show you how to check the materials on this type of circuit board. I apply flux on the materials in order to renew the solder on the circuit board. Then I hover the hot air gun over the circuit board. I replace the other parts that I removed from the circuit board. I clean the circuit board using isopropyl alcohol. Don't forget to subscribe to my channel and share the video so you don't miss new videos.